my research topic is substitution effect on the photophysical properties of imidazole conjugates and their anion-sensing. And first, you can see my title. It's about aggregation-induced emission effect, and this AI effect describes the photophysical phenomenon in which non-luminescent molecules in solutions are induced to show bright emission upon aggregate formation as a result of restriction of intramolecular motions caused by intermolecular direct interaction. And the greatest advantage of AI luminescence is the highly efficient radiative transition in aggregate states for practical application. And next, our study addresses the challenges by designing molecules derived from imidazole with diverse push and pull electron groups, and exploring their photophysical properties and evaluating their potential for selective and sensitive detection of specific ions. The imidazole conjugates with electron withdrawing groups exhibit a fascinating ISIT characteristic, resulting in a distinctive ray-shift in emission. This phenomenon underscores the significant impact of electronic properties on the photophysical behavior of the newly synthesized imidazole conjugates. And the research focuses on studying the spectroscopic properties and affinity for CNI ions. The expected outcomes of this research include the development of highly sensitive and selective fluorescence chemical sensors with applications in ion sensing and potentially fingerprint imaging. And here shows the distinct morphologies of each compound. The first one, DIAOMe, appears as a powdery substance, and DAIN showcases small grounds, and DIAH maintains the powdery state. When under UV lamp, both DIAN and DIAH exhibit intense fluorescence, emphasizing the solid nature of their features. Thus, observation has sparked our interest, leading us to initiate the thorough investigation aimed at gaining deeper insights into the fluorescence characteristics exhibited by this compound. And next in this figure, you can see 3 fluorescent molecules, each with distinctive substituents, were prepared as solutions at concentrations ranging from 1,000 micrometer to 10 micrometer. This concentration and to explore the fluorescence phenomena across a broad concentration spectrum. A clear trend emerges, indicating that within the same solvent, the AI effect becomes increasingly pronounced as the concentration rises. The solution images under UV lamp in the figure vividly portray the enhanced fluorescence intensity corresponding to elevated concentration, further confirming the manifestation of the AI phenomenon. Consequently, these molecules can be professionally categorized as exhibiting AI characteristics. And explore of preferential interaction of imidazole containing derivative with different ions. We employ diimidazole as the solvent and introduce a variety of ions into the system. You can see in the picture, both DIAOME and DIAN demonstrated a discernible selectivity for CNIIL. In the presence of CNIIL, the DIAOME solution underwent a noticeable transition in color from green to colorless when exposed to visible light. Accompanied by an intense blue fluorescence emission under UV light. Conversely, for DIAN, the solution exhibits the color change from green to brown under visible light, and the fluorescence was effectively quenched when exposed to UV light. This distinct response underscores the selectivity nature of these molecules, particularly in their interaction with CNIIL. And here we use these three compounds into fingerprint imaging and to assess the fingerprint imaging abilities for the three fluorescent materials. Various surfaces with distinct characteristics were chosen for the application of pattern fingerprints. The surfaces were classified into non-porous surface like glass-like tinfoil, and porous surfaces like ceramic ball paper plate. Variation in material type and background color can influence the efficiency of fingerprint imaging. And the fingerprint imaging images on the four surfaces reveal distinct behaviors. DIAOME exhibit partial powder adhesion to fingerprints, resulting in less pronounced yellow fluorescence along the fingerprint contours. In contrast, DIAN and DIAH display uniform adhesion on fingerprint ridges in paper cups and ceramic bowls under daylight. While under UV light, fingerprint imaging and fluorescence colors were visible. The specific fingerprint patterns remain discernible. And DIAN demonstrated less fluorescent fingerprint imaging with partial powder adhesion to fingerprint on non-porous surfaces. DIAOME and DIAH exhibit clear powder adhesion on fingerprints, presenting more distinct and clear fluorescent colors. Considering both absorption, performance, and fluorescence properties, DIAH emerges as a suitable sample for primary fingerprint features analysis. And here's my conclusion. Sheer characteristic across those three molecules was the increased fluorescent intensity with rising concentration. And that's the first page I talk about the AIE properties. And further exploration of characteristics involves the interaction with an ion using UV visible and fluorescent spectroscopy. And based on fingerprints imaging results, all these three materials prove effect in visualizing fingerprints on non-porous surfaces. In considering the performance of these materials in fingerprint imaging, they exhibit feasibility as potential fingerprint developers in crime scenes. and providing favorable assistance in the field of chemical sensing and criminal investigation. And my presentation finished. Thank you, everyone.